Hi students, welcome back to ChemOrgChem. So in this JEE Chemistry Insight series, we have been exploring the solution for previous year JEE Chemistry exam papers. If you are new here, don't forget to subscribe and hit the bell icon for notification. So let's see what's today's problem. Today we are going to tackle a question from JEE Main 2025. So which is a interesting multi-step organic synthesis problem that touches on oxidation, production, Grignard reaction and reduction. So it is a great exercise in understanding functional group transformations and other reagent reactivity. So here is the question. So here you see we start with a cyclic alcohol react with excess of chromium trioxide, then with a diol under acidic conditions, followed by methyl magnesium iodide and followed by acid workup, and finally sodium borohydride and reduction to get our final product S. So the question asks for the mass of zero point 0.1 mole of S. So here they given atomic weight of carbon, hydrogen as well as oxygen. So let's see how to solve this problem step by step. First, you write it down our question. So our starting compound, starting molecule is alcohol. So now you see this compound contains primary alcohol as well as secondary alcohol on cyclopentane ring. So when we use chromium trioxide, so which acts as a strong oxidizing agent, therefore both alcohols will be oxidized to their highest possible oxidation state. So we know that primary alcohol, when it oxidizes, that initially produce aldehyde. At the same time, secondary alcohol under this condition oxidize into corresponding keto functional group. So I already stated that chromium trioxide is a powerful oxidizing agent. Therefore, here aldehyde again oxidized under chromium trioxide that produce this cyclopentanone carboxylic acid. So this is our intermediate P. So this sequence of reaction is known as oxidation reaction. So our intermediate P is 2-oxocyclopentane carboxylic acid. In next, P going to react with 1 mole of ethylene glycol under acidic condition. So here the acid will catalyze the formation of a cyclic ketol. So here you closely look our intermediate structure. So intermediate contains carboxylic acid functional group and ketone functional group. So this ethylene glycol going to react keto functional group only. So as per this reaction condition, so this ethylene glycol now react with ketone functional group. So resulting that produce this cyclic ketol as a intermediate. So this is our intermediate Q. So here closely look what happened. So now two hydrogen atoms from ethylene glycol and one oxygen atom from this ketone functional group. These three of them combined the formation of water molecule. At the same time, here cyclic ketol is formed. So this is the common strategy to production of ketone functional group in order to prevent the ketone from reacting in subsequent step. Our intermediate Q now has a carboxylic acid functional group and produced ketone as a cyclic ketol. So this step is known as production. Now this intermediate Q going to react with methyl magnesium iodide. So which is a crucial step. So this is where we need to be careful about reactivity of Grignard reagent. Since Grignard reagents are powerful nucleophiles that readily attack aldehydes and ketones, so their reaction with carboxylic acid primarily involves a deprotonation. So how deprotonation going to take place? So now you see this methyl carbon now quickly take the proton from this carboxylic acid. So resulting that generation of this corresponding carboxylate ion. So here you should note that this cyclic ketal group not react with this methyl magnesium iodide. So now I hope most of them could understand why they given production step before. Since once you produced this keto functional group, so that produce the cyclic ketal, now the cyclic ketal never participate this Grignard reaction. So here simply what happened, acid base reaction only takes place. So then comes to the acidic workup. So this will protonate this carboxylate ion salt back to the carboxylic acid and also hydrolyze the ketal regenerating ketone. So here what happened? Simple deproduction and protonation takes place to produce this corresponding intermediate. So which is R. So now you see this P and R both are same only. So the name is 2-oxacyclopentane carboxylic acid. So therefore, the production and deproduction of ketone allowed us to carry out selective reaction if other electrophiles were present. But here the Grignard primarily reacted with more acidic proton. So finally, this R is treated with sodium borohydride, so which is a mild reducing agent, selectively reduces aldehydes and ketones to primary and secondary alcohols respectively. So now you see in our R intermediate contains only keto functional group. In general, carboxylic acid are generally not reduced by sodium borohydride. So therefore, when we use sodium borohydride, that selectively reduces this ketone into their corresponding secondary alcohol. So here what happened? Reduction reaction takes place. So this is our final product. Yes. So let's moving on. So this is our final product S, which is 2-hydroxycyclopentane 1-carboxylic acid. So in our question, they asked to find out the how much gram weigh the zero point 0.1 mole of compound S. So here they given atomic weight of carbon, hydrogen and oxygen. So in order to calculate zero point 0.1 mole of compound S, so first we need to calculate the molar mass of this compound S. So for that first we should count the how many carbon atoms are present in this compound S. So here you can number, you can start the number from this carbon. So here there are 6 carbon atoms are present. So therefore 6 carbon, then 6 into 12, which provide 72. So next we should see how many oxygen atoms are present in this compound. So here there are 3 oxygen atoms are present. So therefore 3 oxygen. So here each oxygen gets 16. So 3 into 16, which produce 48. So next we should see how many hydrogen atoms are present in this compound. Yes. So for our convenience, we can redraw the structure like this. Now you count the how many hydrogens are present in this compound. Yes. So here there are 10 hydrogen atoms are present in this compound. So therefore 10 into 1 equal to 10. So now you add all these values. So that produce molar mass of compound S is 130. So now we successfully found that molar mass of compound S. So next we can easily calculate the zero point 0.1 mole of compound S. So for that you just multiply zero point 0.1 into 130. So which produce 13 gram. So therefore as per our question, zero point 0.1 mole of compound S will weigh 13 gram of this compound. Yes. That's it for today's problem. So the mass of zero point 0.1 moles of compound S is 13 grams. So this problem highlights the importance of understanding the specific reactivity of reagent like Grignard reagents and how reaction condition can influence the outcome. So I hope you found this explanation helpful. If you have any questions, leave them in comments below. Don't forget to like this video and subscribe for more organic chemistry problems. And thanks for watching, and I will see you in the next video. Bye bye.